In doing the lab, we learned that our motion was constant. Our lines or our slopes were the same. We ended up with several different types of graphs. One graph had position time that looked like this. Okay, so again, it's still constant motion. Position increased as time increased. Another graph we had looked like that, where position increased in the negative direction. As time increased. We had another graph that looked like that, where it was again constant motion, but position decreased. As time increased. We had a graph that looked like that. Positions increasing, time is increasing. Position on the negative side is decreasing. And then it begins to increase as time increases. And finally, we had a graph like that, where it just sat still. All these graphs have something in common. They are a constant motion. And from that, we can find several things. If we graph position and time, constant motion, we can get something like that. One of the things we find with these lines are slope. Slope is rise over run. Okay, so we pick 2 points. I am going to pick a point here and a point here. Okay, we say slope is equal to the change in position over the change in time. Okay, we know that as something changes distance divided by time, we call that velocity. So I'm going to go ahead and name our slope velocity. Okay, in physics, we use symbols. I'm going to convert things to symbols. I know position has a symbol that's X. So position, time has a symbol T. Velocity has a symbol V. So that means V is equal to the change in x over the change in time. Okay, so we know if we pick 2 points off our graph, this is x and this is x. Okay, and this is time and time. Okay, well, this is at the start, this is at the start, and this is at the end. So let's call the start initial. So this is initial, and this is final. So slope is a change in position, x2 minus x1, and in our case, it's x final minus x initial over time final minus time initial. Okay, well, our time initial is right there at 0. So I'm going to say it's 0 because we started the stopwatch every time. It starts always at 0. So that means our velocity is equal to x final minus x initial over t final. Okay. Let's simplify it to something we can see in math class. So velocity final times time final, or velocity final, velocity times time final is equal to position final minus position initial. Rearranging it even further, we know what? We know velocity final times, our velocity times time final plus initial position has to equal final position. So let's just rewrite this and find out what we know. We know from our graph, if we have a graph of position and time, it should be some type of slope that's constant. So that means it is not changing. Okay? It can be positive or it can be negative. But no matter what type of slope we get, we know slope is equal to the rise over the run. And we know position final has to equal position initial plus velocity time final. This is for constant motion.